do a lot of new work. There hasn't been a lot done in this, so I really saw it. You know, since we don't even have quantum computers, hey, there can't be that much work done on them yet. So that, and I was kind of interested in the physics behind it as well. So kind of taking the opportunity to learn a lot more about that as well.
Is it follow on the question Nadine asked? As far as field application, I mean, typically would depend on what kind of math you're using, ultimately. I mean, we're using computers now to generate iteration after iteration of whatever it is we're putting in there. So imagine you had to dig into some quantum mathematics of some sort. So what in there exists that we can relate to, and what do you see as missing?
Yeah, you mean as far as us being able to relate
well,
to how
let's take your
computer
protein
works?
example.
Right.
I mean, there's currently a method of doing this with classical computers and
Right.
certain algorithms that exist that are implemented in order to perform, okay, not great, without great expectations as far as
Right.
results, but we're still getting something. So how would we, I mean, the transformation of this math from the classical application onto the quantum computer, there has to be some, does everybody understand what I'm saying? There has to be some transformation at some point in the mathematics of it.
Right. I think really, for the protein filling example, it's really going the other way. We know how it works, you know, quantum mechanically. We're taking that and expressing it on the classical computers. So I think we're really going a lot towards our existing computers.
That's mainly
But-
matrix
but-
math.
and that's what
I'm
I'm
Right.
saying.
It's mainly matrix math.
Right.
And that's what I'm saying is there any work that's already started perhaps to, now that you have this, I'm surprised you haven't published it, because that would have been a great spin-off for someone who said, well, maybe I need to look at going the other direction with it now. Because
Yeah, definitely. That is definitely
someone who
big
is an
area for
expert
work.
in the field.
Right. Yeah, I think it's an area for more work, definitely.
So Matt, do you see our first jump being a hybrid, classical and quantum, or?
I actually see that being the case for maybe even after, you know,
Exactly.
cheap, because as we saw in the factoring example, you only need a quantum computer for just a little piece.
Exactly.
And it's probably going to be expensive. So, you know, have your classical computer with your billions or trillions of bits or whatever, and then your quantum computer with, you know, maybe a couple hundred or thousand
Qubits, right?
Yeah, that you exploit.
So if you had another 2 months other than taking your wife on a vacation, which I'm sure well deserved, what would you do? What would you add to this when you wrote done?
Really,
Or what's next? Let's put it.
what's next is really just fleshing out the prototype more. I have it to the point where I can do the first couple pieces of factoring, but I can't yet simulate the entire factoring, so it would be just finishing up. And a lot of that too.
That's a hardware issue as much as anything else, though, isn't it?
No, it's really another one of these cases where it's really not documented. Okay, everybody says, you know, you perform f of x on these registers. How do you build those up from the simple, you know, quantum operations? And really, I've come across just 2 references for that, and the second's a rewrite of the first, essentially. So, you know, they say, do this, but they don't say it explicitly what they mean, so it's a little bit of trial and error and digging and kind of trying the math out. So, yeah, that's my next step.
Have you contacted anybody that might kind of sit on the answer to those questions?
No, I haven't. Wouldn't be a bad idea. Wouldn't be a bad idea, but I think I've learned a lot too by kind of trying to, you know, get down in the dirt and kind of trudge through it on my own. You know, work the math out by hand.
It just seems a shame that this would gather dust after this point.
Yeah, we'll see.
And I guess, and when you say classical computers, does that include supercomputers?
Yes. Yeah. Basically, anything that operates on a bit. Any other questions or comments?
So I assume someone's done the math that shows this is equivalent to a Turing machine or a subset of what we mean by
Quantum Turing
computation.
machine, actually. Yeah.
So, okay, now that begs the question, what's the difference?
Without going into too much detail, it's essentially the, you know, you're operating on qubits instead of the bits. Is what it boils down to. And there's a lot of Not a whole lot, but there was some work initially, early on. That's where the work was back in the mid-'80s when people first thought of quantum computers as, kind of here's how they operate differently. Here's a trivial example of something we can do on a quantum computer that you can't do classically. But as far as
It's
that,
not you can't do on a classical, it's just it would take forever and take 10 to the 77.
right.
That's why I was asking about the Turing machine.
Right, given all the atoms in the universe.
Right,
we can do it.
yeah.
But, yeah.
So has anybody done any kind of projections as to NP completeness and what that means in a quantum computing?
Yeah, there has been some work, and it's kind of unknown. They think there's a kind of sphere of problems that can be solved on a quantum computer, and where exactly those bounds lie, no one's really figured out yet. You see from examples like factoring, you can see that it might be able to tackle some of these harder problems we can't do classically, but as far as where those bounds actually lie, to my knowledge, it hasn't been established yet.
So there are some students in here who might pick up this baton. Take it the next step.
Be the quantum Turing machine, for example.
Yeah.
So somebody's next.
We need a couple of minutes while they wait at some. Nobody's moving, I guess.